Okay, welcome back to Chapter 7 of Geometry. These are our homework videos here. This is numbers 46. And so for each of these, we're asked to determine if the pair of triangles are similar. If they are, we put that information in the flowchart. If not, we'd explain why we know they're not. And so, I'm not necessarily going to make a flowchart per se if they're similar. Let's kind of talk through the bits and pieces that match up and why they are similar according to a similarity statement. So this first one, we don't know anything about the sides, right? So in order to get these two triangles to be similar, it would purely be an angle-angle similarity. So we need two angles of one triangle to match the two angles of the other. And so one bit of information we have here is that angle C is the same as angle Y. They're both 42. If we look at the second angle, they don't match up, but we can't just stop here and move on because there's a possibility that maybe the third angle of the one triangle here is 102, maybe this third angle over here is 36. So using triangle sum, we're going to find out what angle B is and what angle Z is. So 180 minus 36 minus 42 ends up being 102. So angle B actually is the same as angle X. And we could stop right there, but I'm just going to find out angle Z over in the other triangle by doing 180 minus 42 minus 102, just to put our mind at ease, to show that yes, this really is 36 degrees, and all three of those angles are the same. But we really only need two of them to show that they're similar by angle-angle similarity. The second set of triangles, it looks like they're both isosceles. This one's isosceles triangle, 6, 6, and 10, and this one is not. So there's no way they can be similar, because if they were similar, they'd have the exact same ratio to go from one side of the triangle to the corresponding side of the other triangle. And there's obviously not the same ratio to go from 3 to 6 as there is from 5 to 6. It's a different ratio, so it can't be similar. So this pair is not similar. This last one here, I know the sides of this triangle, this right triangle, the legs are 3 and 4, which means the hypotenuse is 5. It's a 3, 4, 5 right triangle. And if this leg is 6 and the hypotenuse is 10, then this is a 6, 8, 10 right triangle. So those are our Pythagorean triples, 3, 4, 5, 6, 8, 10. And if we notice, there is the same ratio going from each of the corresponding sides. 3 to 6 is a factor of 2, 4 to 8 is a factor of 2, and 5 to 10 is a factor of 2. So each of those sides match up in a ratio of 2 to 1, which makes it a side-side-side similarity. Any questions about why any of those pairs of triangles are similar or are not similar, or similarity in general? Feel free to leave a question or comment. Otherwise, you're more than welcome to like, subscribe, or share to our geometry channel.